Hello everyone. In this video we are going to discuss about dependence of voltage on reactive power for interconnected system. The previous class we discussed only dependence of voltage on reactive power. Okay, but now we are discussing it for interconnected system. So let us consider a system of two generators as shown here. We are having two generators G1 and G2. The voltage at node 1 or bus 1 is V1. The voltage at bus 2 is V2. We are having a load of P1 plus JQ1 at bus 1, and for bus 2 we are having a load of P2 plus JQ2. Okay, for this system, the scalar voltage difference between two nodes the scalar voltage difference between the two nodes can be written as delta V is equal to Rp plus XQ divided by V, marking it as equation number 1. As we can see, the scalar voltage delta V is equal to Rp plus XQ divided by V, marking this as our equation 1. If in this equation the value of X is very much greater than R, then Q is determined by delta V. You can observe here, if the value of X is very much greater than R, then the value of Q is purely identified by delta V. And for time being, let us assume the phase angle of G1 is ahead of G2, which means V1 is greater than V2. The voltage V1 is greater than V2. This means if the value of V1 is greater than V2, it clearly means that there is a flow of active and reactive power from bus 1 to bus 2. Okay, since V1 is greater than V2, there is a flow of active power and reactive power from bus 1 to bus 2. Fine. For this assumption, if we want to draw the phasor diagram, here we can see we are having a phasor diagram for V1, voltage V1 is greater than V2, and here we can clearly observe ID is the component of current in phase with V is determined by the angle delta. Here you can see the angle sustained is delta, and it is in phase with the voltage V. Okay, and the active power P, as we discussed here, the active power P depends on ID. Active power P depends on ID, hence it is dependent on the angle subtended delta. You can mark that on also. Similarly, IQ, the current component, is in quadrature with the voltage V, depends mainly on difference in V1 minus V2. IQ depends on V1 minus V2, difference in the voltage. Okay, hence since IQ depends on V1 minus V2, we can say Q, reactive power Q, depends on V1 minus V2, or the voltage difference, we can say it. Okay, for this phasor diagram. If we go further and if we vary the generator excitation, in the previous case we assumed V1 is greater than V2. Okay, for that we are looking at here the phasor diagram and the equations. And if we go further and vary the generator excitation such that V2 is greater than V1. V2 is greater than V1. Then the direction of reactive power flow is reversed. If V2 is greater than V1, power real and reactive power flows from V2 to V1 or bus node 2 to node 1. Okay. And for that we are having the phasor diagram. Yeah. This represents the phasor diagram for V2 greater than V1 or V1 is less than V2. Okay. Thus the direction of active power flow can be controlled by adjusting the prime mover inputs, and the direction of reactive power flow can be adjusted by the excitation of the two generators. Now we can see we can adjust the reactive power flow, we can control the reactive power flow in a direction depending on the excitation. If you excite generator 1 by a greater value compared to generator 2, the power flow will be from bus 1 to bus 2, and if we excite generator G2 more such that V2 is greater than V1, then the flow will be from bus 2 to bus 1. Okay. And if the value of R, from equation 1 we can see, if the value of R, if it is very much smaller than X, as we discussed earlier, these two operations are independent of each other. Okay. If the value of R is very much smaller than X, these two operations are independent of each other. If the reactive power is generated, the voltage of the bus will rise. We all know if you generate reactive power, the voltage will be increased in the bus. Okay. If you make the reactive power 0, and for time being if we continue with considering if for reactive power Q is equal to 0, then there will be no voltage drop between bus 1 to bus 2. Okay, from equation 1 here we are having equation 1. If it is 0, the voltage drop will be not much compared to the previous one. If we mark Q is equal to 0, it will be neglected. And from equation 1 we can write the receiving end voltage and the reactive power as Q2 is equal to V2. For bus 2 we are marking it for bus 2. Q2 is equal to V2 into delta V minus R into P2 divided by X, marking it as equation number 2. And we can see that X into Q is delta V into V. Here having delta V into V. Here it was plus RP, and we are taking it to LHS minus R into P whole divided by the coefficient of Q is X, and here we are having the X and the denominator. And now we got equation 2. And if we keep the voltage V1 and V2 constant, if the value of V1 and V2 remains constant, the change in voltage remains constant, which means if V1 and V2 are constant, which means delta V is also constant. Okay, which means this component, the whole component remains constant. Therefore Q2 will be equal to K minus R divided by X into P2. V2 into delta V divided by X is marked as K here. Okay, marking it as equation number 3. Okay, and if you continue the same, if P2 changes, if the real power changes at bus 2, if it is changed by a small value, if we consider it as delta P2, if we change the real power by delta P2, then the equation 3, this equations becomes delta Q2 is equal to R divided by X into delta P2, marking it as equation number 4. The small change in P2 will raise a small change in Q2. Okay. The only thing that we affect here is, since K is constant, if we change P2 by small value delta P2, it affects the reactive power by small change in Q2 by delta Q2. Okay. And from this equation, equation 4, it is obvious that an increase in P2 causes an increase in Q2 proportional to R by X. And here we can see, thus by this equation we can state that we can control the voltage by injection of reactive power of correct sign. Okay, by injecting a reactive power of correct sign, we can control the voltage. Okay, this is about dependence of voltage on reactive power for interconnected system. Thanks guys. If you need anything else, please put a comment on my Dropbox. I will reply. Thank you.